And welcome back to another math video. In this video, we're going to be covering questions 5 through 8 of the St. John's DSG Grade 10 math exam from 2019. In question 5, we're going to be algebraic expressions, and we're going to be leaving our answers in the positive exponential form. So let's jump right into it. We start off with x to the power of 10 over y to the power of negative 5, everything to the power of negative 2 over 5. Remember the laws of exponents. When you have a bracket and a fraction to the power of an exponent, that exponent applies to the exponents in your fraction. So this is going to be x to the power of 10 times negative 2 over 5 over y to the power of negative 5 times 2 over 5. So 10 times negative 2 over 5 gives us x to the power of negative 4. And 5 times negative 2 over 5 is going to give us y to the power of 2. These negative 5s cancel out through cross multiplication. And now remember, we want our answer in the positive exponential form. So we can rewrite this as by bringing the x to the power of negative 4 to the denominator and rewriting this as 1 over x to the power of 4 y squared. So let's rewrite that neatly on the other side. 5.1. Our answer is 1 over x to the 4 y squared. That's your 3 marks. For 5.2, we have 6a to the power of negative 2 times 3 to the power of 3a plus 1, everything over 18a. So here, we're going to have to change our numbers into their prime bases. Let's actually take a screenshot of this and move somewhere where we have a little bit more space. There we go. So we have 6a minus 2. How would we write this in its prime form? 6 can be rewritten as 2 times 3. And all of this is to the power of a minus 2. So that's a minus 2. 3 can just remain as it is because 3 is a prime number. 3 to the power of 3, a plus 1. And how about 18? Well, for 18, we can write, we know that 18 is 2 times 9. So 9 can be rewritten as 3 squared. So we can have 2 to the power of a times 3 squared times a. So that's going to be 3 to the power of 2a. So we've changed it into its prime basis. And now we're going to expand these multiplications that we have over here. So we're going to have 2 times 3 we're going to have 2 times a minus to the power of negative 2 times 3 to the power of a minus 2 times 3 to the power of 3a plus 1. And we're going to keep our denominator as it is for now. 2 to the power of a times 3 to the power of 2a. Now we can combine this 3 to the power of 2a minus 2 and 3 to the power of 3a minus 1 plus 1. Because we know if the bases are the same and we're multiplying, we can add these exponents. So if we have a minus 2 plus a plus 1, a plus a gives us 2a negative 2. Oh, this is 3a. So a plus 3a is going to give us 4a. Negative 2 plus 1 gives us just minus 1. So we now have 2a minus 2 times 3 to the power of 4a minus 1, everything over 2a times 3 to the power of 2a. And now we just use the laws of exponents again. If the bases are the same and we're dividing, we subtract the exponents. So a minus 2 minus a is going to give us just 2 to the power of negative 2. 3 to the power of 4a minus 2a gives us 3 to the power of 2a, because 4a minus 2a minus 1. And then we're going to simplify further because we want this in positive exponential form. So 2 to the power of negative 2 is the same as 1 over 2 squared. And 3 to the power of 2 minus 1 is the same as 1 over 3 to the power of 2a minus 1. So our final answer should be 3 to the power of 2a minus 1 over 4. For question 5.3, we have 7 times 5 to the power of m plus 5 to the power of m plus 1 over 5 to the power of m minus 1 minus 5 to the power of m. So here we're going to have to factorize. So we'll have 5 to the power of m times 7 plus 5. And in our denominator, we'll take out 5 to the power of m as well, times 5 to the power of negative 1 minus 1 to get our negative 5 to the power of m. So how are we going to simplify this? Well, 5m and 5 to the power of m and 5 to the power of m cancel each other out. 7 plus 5 gives us 12. And then we have 5 to the power of negative 1, which is the same as 1 over 5 minus 1. So this is the same as 12 over negative 4 over 5. And if you simplify this in your calculator, you'll get negative 15. And that's it for question 5. Let's jump into question 6, where we'll be solving for x. In 6.1, on the left-hand side, we have 4 minus 2 times 2x minus 5 is equal to negative x minus 5. So we're going to distribute and get the correct signs here. So let's actually work on it up here. 6.1. So 4 minus 2 times 2x, or negative 2 times 2x is going to give us negative 4x. Negative 2 times negative 5 is going to give us positive 10, is equal to negative x. That negative and negative 5 is going to give us a positive 5. Now we're going to bring our x's to one side and our numbers to the other side. So negative x plus x would give us negative 3x. If we subtract 10 on both sides and subtract 4 on both sides, that's going to leave us with minus 9. And if we divide both sides by negative 3, x is equal to 3. That's it for 6.1. 6.2, we have dx minus eq is equal to fx. Now we need to just take out a common factor. If we take x times d minus f, we can set that equal to eq just by rearranging our formula. So x will then equal to eq over d minus f. So rearrange our formula, common factor x, and we are left with x is equal to eq over d minus f. Now for 6.3, we have 1 over x plus 3 is equal to x minus 1 over negative 3. So we need to find our lowest common denominator here, which is going to be negative 3 times x plus 3. So we have 1 over, okay, let's just write down our LCD. LCD is going to be negative 3 times x plus 3. So we can rewrite this and have negative 3 on the left-hand side, and on the right-hand side, we can have x minus 1, x times x plus 3 from our cross multiplication. And we'll have negative 3 is equal to, if we FOIL, x times x gives us x squared, x times 3 gives us positive 3x, negative 1 times x gives us minus x, negative 1 times 3 gives us minus 3. Still with our negative 3 on the left-hand side, we have x squared. 3x minus x is just going to give us minus 2 plus 2x minus 3. If you bring everything to the right-hand side, set the left-hand side equal to 0, we'll be left with x squared plus 2x. Because by adding 3 on both sides, these 3's will cancel each other out. So 0 is equal to x squared plus 2. If we can take out a common factor here, we'll have x times x plus 2. So we have two options. X is either equal to 0 or x is equal to minus 2 from our bracket over here. That's it for 6.3. 6.4, we have an inequality. Let's rewrite it on this side. We have negative 7, 2 minus 3x less than or equal to 5. There we go. We're going to subtract 2 to get negative 3x alone. So negative 7 minus 2 gives us negative 9, negative 3x. And by subtracting 2 from 5, we have 3. And then move up a little bit. We're going to divide both sides by negative 3 to get x alone. So if we divide by negative 3, divide by negative 3, well, also the sides by negative 3, the signs are going to change. So we're going to have 3. This is going to be a greater than sign. We'll be left with x, and we will be left with negative 1 on the side. Let's rewrite this nicely. So x must be greater than or equal to negative 1 or less than 3. And we have solved for x in this inequality. Oops, looks like I've lost. There we go. Question 6. So 6.5, we have 3x squared plus 5x is equal to 1 over 81. Interesting one. How are we going to do this? Well, we're going to, let's move this way. We can rewrite this as 3x squared plus 5x is equal to 3 to the power of negative 4. So 1 over 81 can be rewritten as 3 over negative 4 because 1 over 81 is the same as 1 over 3 to the power of 4. And if we just make it a negative exponent, it's going to be negative 4. So now we do this because we want to have the same bases on each side. So because the bases are the same, we're going to disregard the bases and we're going to just have x squared plus 5 to the power of x. Oh no, this is just 5x. Sorry, not 5 to the power of x. This is just 5x. So this is x squared plus 5x is equal to negative 4. Bring the 4 over to the left-hand side. We have x squared plus 5x plus 4 is equal to 0. And now we just factorize this trinomial. What two numbers, when multiplied, are going to give us 5 and 4? When we add them together as well, we can have x plus 1 and x plus 4 equals to 0. That leaves us with x is either equal to negative 1 or x is equal to negative 4. And that's it for question 6. Let's take a look at question 7, which has to do with distance and time. Question 7. Plane A takes off from King Shaka International Airport heading towards Cape Town International Airport. At the same time, plane B, so maybe let's highlight them in different colors. So plane A, it leaves from King Shaka in Durban and it's headed towards Cape Town. Then we have plane B, which takes off from Cape Town and it's heading to King Shaka. So these planes are going in opposite directions. Same direction, just in opposite, same destinations, but just in opposite directions. Right? So this one's going east to west, this one's going west to east. Now, plane B, we're told, is flying 20 kilometers slower than plane A. So this plane is flying at X kilometers per hour, and plane B is flying at X minus 20 kilometers per hour. The airports are 1,634 kilometers apart. So we have a distance here. And the planes meet after 54 minutes. So that means that they pass the same point after 54 minutes. Now we're asked to calculate the distance from King Shaka International Airport at which they meet. So, and the speed of each plane. So we need to find out where exactly did they meet? What's the distance from King Shaka International Airport? And what was the speed of each plane? Let's summarize that information. So let's use purple for plane A. And let's use blue for plane B. And we're going to have distance, speed, and time. So plane A, we were told, or we figured, is travels a distance of x. And plane B, since it's going from Cape Town to King Shaka, it's 1,634 minus x. This is the distance where the two planes meet. So it's x distance for plane A and 1,643 minus x. We're told the airports are 1,634 kilometers apart. Plane B is leaving from Cape Town towards King Shaka. So it's 1,634 minus x. So plane A is leaving from King Shaka. So that would be x kilometers. The speed at which they're traveling, we know speed is distance over time. We were told in the question that it took 54 minutes to get to the point where they met. So if we divide that by 60, that's going to give us 0.9 hours. So it took both planes 0.9 hours to get to the same point. So speed, we said, is distance over time. So that would be x over 0.9. And for plane B, that would be 1,634 minus x over 0.9. So now we can create an equation from the variables that we have. We can take the speed of plane A, x over 0.9, and make it equal to the speed of plane B, 1,634 minus x over 0.9 plus 20. Remember, plane B is traveling 20 kilometers per hour slower than plane A. Now we can simplify this. Our common denominator is 9. So we can have x is equal to 1,634 minus x plus 18. If we bring the x to the other side, add x on both sides, we're left with 2x. Let's get the pen working. 2x is equal to 1,634. 1,634 plus 18 is 1,652. Divide both sides by 2, and x is equal to 826 kilometers. So now we can figure out the speed of plane A. So the speed of plane A is the distance over 0.9. So that's 826 over 0.9. And that's going to give us 917.78 kilometers per hour. The speed of plane B is 917.78 minus 20, which is 897.78 kilometers per hour. So we found the speed of both planes, plane A, plane B, as well as the distance at which they meet. Now for the last part of the video, we're going to do some trigonometry. Simplify the following to correct to 2 decimal places. Here we can just plug in these numbers into our calculators, and sine of 35 gives us 0.57. Remember, to 2 decimal places. Sine 50 over cos 50 gives us 1.19. And tan squared 37, remember, is tan of 37 squared, which is the same thing as tan of 37 times tan of 37, which gives us 0.57.